Hypothalamus Artificial Intelligence, HI. It presents companies in the process of digital transformation, its offer of professional services and the supply of algorithms of highly complex multi-problem mathematical models. These services are called competitive electricity markets, Nash Cournot and Stackelberg equilibriums, case, Superintendence of Public Services in a Latin American country. To provide these services, HI is supported by its business partners, GAMS, IBM and TD SYNNEX, all of which are producers of artificial intelligence technologies. HI is a company at the forefront of high-performance artificial intelligence. Electricity system and wholesale market optimization models make up a flexible decision support system that provides different types of services in an integral way. They can be classified into integrated dispatch of generation plants, optimization of generating agents, and predictive analytics of stochastic processes. HI Power is a decision support system that has been developed to support the decision-making processes of agents participating in the electricity and/or natural gas markets. HI Power is composed of a set of optimization models that describe the supply/demand process of electricity and natural gas. From this point of view, it determines the partial equilibrium point of the electricity and gas markets under conditions of economic efficiency. The models developed by HI for electricity wholesale systems and markets are dispatch models, economic perfect dispatch, economic regulated dispatch, Cournot-Nash equilibrium dispatch, electricity and gas dispatch, and unit commitment. Complementary models, electricity dispatch and financial analysis, maintenance of regional national grid, electricity supply chain design, and risk management, and energy trading and risk management. Traditionally, the optimization models in the electricity sector have been individual modeling with exogenous coordination between models, based on multi-stage stochastic programming, and using large-scale optimization methodologies. The differences provided by HI Power are integrated holistic modeling, scientific risk modeling, multidimensional uncertainty, parallel optimization, and autonomous real-time distributed optimization. Project, electric and gas system and market dispatch for Peruvian transmission expansion plans. Challenge, to develop an integrated electricity and gas dispatch model to support the optimization of the national plan of transmission in Peru. Solution, design and implementation of a set of mathematical models that includes simulation of simultaneous optimum dispatch of electricity and natural gas systems, and the evaluation of multiple expansion uncertainty scenarios, to build Pareto curves that support the selection of a robust expansion plan. Result, MODPlan, a long-term stochastic parallel optimization model that includes simultaneous optimum dispatch of electricity and natural gas systems. The model was linked to the Excel environment used by the end user. Since 2014, MODPlan has been the official model, by law, used by ISO of Zine, to carry out transmission expansion plans. Project, natural gas system and market dispatch model. Challenge, to implement a mathematical model to simulate the transportation production and consumption of natural gas that describes its processes of supply and demand. Solution, design and implementation of an optimization model that includes the following types of nodes. Production fields, consumption center, natural gas demand nodes discriminated by demand sector, among which are industrial, vehicular, electricity generation, commercial and residential, and ports, terminals, that can receive and/or send LNG. It is associated with liquefaction and/or regasification plants. Result, MODPlan gas is a long-term stochastic parallel optimization model that simulates the optimal dispatch of LNG systems. MODPlan, power and gas, by law, it is the official model in Peru for the analysis of the expansion plan of the Zine transmission network. Project, electric system and market economic SSDP dispatch. Challenge, the Superintendence of Public Domestic Services of Colombia, SSPD, hired HI in 2010 to implement a system of models to simulate joint operation of the electricity market and the gas market in Colombia. Solution, implementation of a mathematical model that simulates the economic electricity dispatch of the national transmission grid in Colombia. The model include the gas transport system, the production, and handling of GNL by liquefaction and regasification. Result, MODSE, is a version of high power to support the simulation of the electricity and gas transmission grids in Colombia. The model was customized to include data known to the SSPD as the system supervisor, for example, contracts between agents. MODSE was developed in C++ as a SaaS service in the cloud. Project, Decision Support System, DSS, to supervise the wholesale market of electricity. Challenge, to develop a DSS to surveillance activities for the electricity and natural gas sectors. Solution, design and implementation of the DSS that included the following models: electricity and gas dispatch, competitive electricity market equilibrium, real dispatch of the interconnected system considering the long-term contracts of purchase-sale of natural gas and electricity, and financial statements of the electricity generators considering the real dispatch, and in Stackelberg market economic model, with two types of agents, price makers, and price takers. Result, a DSS that integrates the models required by the supervisor, based on high power. High power. Interconnected electrical systems dispatch optimization model. MODSE. Interconnected electrical systems dispatch optimization model. In Spanish, Modelo de Optimización del Despacho de Sistemas Eléctricos Interconectados. This experience extends to the models implemented in 2008 and 2010 for the SSPD, which were called MODSE. Standard MODSE simulates electricity and gas transmission networks. The model was customized to include data only known to the SSPD, such as electricity and gas contracts between agents, and Nash Cournot MODSE simulates competitive markets such as Nash Cournot and Stackelberg, to obtain more realistic shipments of the Colombian market, and analyze the exercise of market power by the dominant agents. It includes the following models. The standard MODSE is described below, taking as a reference the official presentation of the SSPD at that time. The video. High power. Autonomous optimization software for electric sector enterprises. Presents more information about high power. High power. Competitive electricity markets. Nash Cournot and Stackelberg equilibriums. The ELE, Electricity Economic Dispatch, model optimizes the dispatch of generation infrastructure, minimizing the cost of operating the electricity system, which simulates a perfect electricity market. ELE is the core model of high power, as its equations/constraints are used in multiple specific models that the agent requires to address decision support needs. From EDD, 3 models of complementary dispatch are built. Economic perfect dispatch, economic regulated dispatch, Nash Cournot equilibrium dispatch, and unit commitment. The first 3 models are oriented to planning and the fourth to real-time programming. 3 types of connectivity of the generation system and the transmission power grid are considered. Ideal single node, ideal dispatch ignoring the transmission system. Electric transmission network connectivity based on the detailed connectivity of the electricity transmission system using bars and circuits. Operative areas connectivity, when the user does not have, or does not want to use, the detailed configuration of the electricity transmission grid, it is possible use the connectivity based on operational area //app. Blaster online. com/speech low/changelogs including limits on the transfers between areas. Interconnection electricity, gas integrates electricity network with natural gas network. Interconnection electricity, water can be fully detailed, including travel times between nodes and transport restrictions in water resource conduction channels. Economic regulated dispatch, delivery of plants that minimizes the cost of operation of the interconnected system and includes representative aspects of the regulatory of the electricity market being simulated. It does not correspond to a model of economic equilibrium, however, it is an easy and fast way to represent regulatory considerations based on optimization models. Cournot-Nash equilibrium, dispatch of plants oriented to the simulation of competitive electricity markets with agents that can influence their decisions on transactions occurring in the market. It can be used to, among others, project the dispatch of a competitive market, and study the exercise of dominant power of agents. In competitive markets, hydropower may be lower than in markets dispatched by mathematical models. The effect of the difference on the results of the two models is observed below: economic dispatch versus competitive dispatch. The image taken from the lecture Bid-Based Dispatch in Large-Scale Hydroelectric Systems, given by Luis Barroso, presents the production of hydroelectric energy in a competitive market, in which agents take strategic positions. In this case, the hydroelectric power will be lower than in the markets dispatched by mathematical models of traditional economic dispatch. On the other hand, if spot prices are analyzed, the strategic position of generating agents will produce higher spot prices than low-cost dispatch models. Obviously, if an agent uses low-cost dispatch models to estimate their revenue, price by quantity, the financial accounts may not add up. The dominant agents, who exercise the dominant position, will make more money. In this way, the market and the dominated agents will deposit the surplus profit obtained by the dominant agents. This is the main problem faced by the market supervisor. Define a market situation as the exercise of a dominant position. Determine their magnitude, and determine the agents that cause it and that take advantage of it. The White Paper. Modelos de Máxima Ganancia en el Sector Eléctrico. In English, Maximum Revenue Models in the Electricity Sector. Presents the theoretical framework that underpins the MODSE models. The theory of the equilibrium of a perfect market establishes that the equilibrium point is the one that maximizes the social surplus generated by society, which is constituted by the surplus of consumers plus the surplus of producers. The diagram describes the situation. From the mathematical point of view, the equilibrium point is the one that maximizes the integral of the price by the quantity minus the cost of supply. Since economic rationality is assumed, producers will stop producing when the surplus produced reaches zero, defining the solution point of the problem. The reason why market power is exercised is based on the maximization of the profits of the dominant agent, which are generated by transferring part of the surplus of the dominated agent to the surplus of the dominant agent. The bad thing about contracting the amount traded, in this case hydroelectric generation, is the decrease in the social surplus, and therefore in the wealth that the market produces for society. The economic rationality of the dominant agent lies in the fact that its income is a function of the quantity generated and that its maximum, considering the increase in price, is in an amount lower than the ideal for the society. By knowing the behavior of the dominated agent, the dominant agent can determine the price and quantity that is convenient for him to maximize his surplus, to the detriment of society and the dominated agent. The video. Planificación y programación de sistemas de electricidad y gas. Marco de referencia y modelos matemáticos. Presents more information about the models of high power. MODSE, computational implementation. This session has been extracted from the MODSE Mathematical Modeling Manual. It therefore reflects the state of modeling in 2008 to 2010. Today, high-power MODSE has access to all the advances made in artificial intelligence for decision-making. The main features of MODSE implementation are: implementation of all components of mathematical models in C language, interface of the MODSE C program with the COINP and GLPK optimization libraries of free use, interface of the MODSE C program with the commercial optimization library CPLEX v11.x, loading data from text.txt files, in table format, with header for fields on the first line and data separated by commas. The results are expressed in text files, .opt, in table format, with a header for the fields in the first line and data separated by commas, and front-end on the web under a PHP program that allows users to run remotely the models on a web server, export the parameters, input data, from the user's access point to the web server, and import the results from the web server to the user's access point. The image presents the flowchart of the mathematical modeling process. The process, framed in the dotted box, defines the scope of the algorithm to be implemented, which in this case became a C program, a general-purpose computer language. The current version of high-power ModSay is available in 4th-generation algebraic languages, such as GAMS, IBM OPL, AMPL, Mosel, and others. ModSay uses standard concepts and elements of Optech's modern modeling. Basic mathematics elements: index, set, parameter, variable, constraint, objective function, and decision support systems elements. Problem is a set of constraints and variables, and other problems. Model is a set of problems and data flows, and other models, and ModSay, the model, is a set of models and data flows. Optech's optimization expert system is the generative artificial intelligence used by HI to generate the necessary computational code. It was used to produce ModSay. The image presence, in Spanish, the equations of conservation of matter in reservoirs. All of these equations are part of the Optech's expert system. The image presence part of the program in C, related to the VFE equation. The generative artificial intelligence process is simple. The algebraic model is encoded in the Optech's expert system, in the tables of the information system, and from there the C program and other tools are generated to consult the database. The structure of the ModSay software system includes PHP interface to manage the information system and control execution of ModSay, on the web or on a local computer, the process of generating matrices in the C program, which includes Bender's decomposition routines, and connectivity to the solvers that ModSay can access. The function of C program is to generate the connectivity matrix with the solvers. The input files to the PHP program have the .text extension and the output files .opt. ModSay can work in a wide area network, in which several workstations share the information system and the algorithm programs. This possibility was not in common use at the time ModSay was created. ModSay, Information System and Visual Interface. Information System. The tables present the data model of the ModSay information system. The table presents the metadata model of the ModSay fields of the information system tables. The Excel table presents the master table of hydraulic power plants. Visual interface. The PHP screenshot shows the login to ModSay on the SSBD server. The user can select the general characteristics of the ModSay model type to be used: deterministic or stochastic. Transmission system, single node, operational areas or transmission network. Hydraulic energy conversion, fixed hydraulic head, or variable head depending on the reservoir level. Solution methodology, monolithic model or Bender's partition algorithm. Access to the database, in .text files, that the user is using, is done from the PHP interface. The user can view the data from the PHP interface. Access to the results database, at .opt files. The results of the variables and constraints are presented. The user can view the data from the PHP interface. Results: case, Ecuador, Colombia interconnection, determinist monthly dispatch, planning horizon, 2 years. The table provides a summary of the costs of the case. The table provides a summary of the costs of the case. The Excel table presents the results of the primal variables stored in the secondary table of relationships between hydroelectric power plants. It corresponds to the water flow between plants. The Excel table presents the results of the dual variables stored in the secondary table of relationships between hydroelectric plants and reservoirs. The graph presents the profile of the reservoir. The graph presents the profile of hydroelectric generation. The graph shows the marginal cost of demand for the bars, divided by 7 hourly blocks, B1 to B7. The graph presents the profile of the marginal value of water in reservoirs at the end of each period. Like Herbert Simon, hypothalamus artificial intelligence believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.